An object moves horizontally and follows an equation for its location in feet as a function of time in seconds as x of t equals negative 3t squared plus 12t plus 2. T is between 0 and 3 inclusive. Determine the parts A through H. Our position as a function of time, x of t is negative 3t squared plus 12t plus 2. For part A, we want to find the velocity as a function of time. The velocity as a function of time is the derivative of the position as a function of time. The first term is power. We'll bring down the power, multiply with the negative 3, subtract 1 from the power. The second term is a constant times t. The derivative will be the constant. Third term is a constant with no t. The derivative will be a 0. Our velocity as a function of time will be negative 6t plus 12. For part B, we want to find the time or times when the velocity is 0. And that's found by taking the velocity function of time, setting it equal to 0, and solving for t. Let's subtract 12 from both sides. Let's divide both sides by negative 6. And negative 12 divided by negative 6 will be 2 seconds. For part C, we want to know the maximum horizontal location reached, and for part D, we want to know the minimum horizontal location reached. Those will be either the position when it starts, the starting time is a 0, as seen right here, or the position when it finishes, when it ends, that's a time equals 3, or anywhere in between when the velocity was a 0. So we want to evaluate the position at the starting time of 0, the turnaround time at 2, and the final time of 3. Each of these, we will plug this in for the t in the position function. X of 0 will be negative 3 times 0 squared plus 12 times 0 plus 2. Negative 3 times 0 squared is 0, plus 12 times 0, which is a 0, plus a 2. Negative 3 times 0 is 0, plus, and 0 plus 2 is a 2. 0 plus 2 comes out to 2, and we're at a location of 2 feet. Now, at a time of 2, the time when the velocity is a 0, which will be a turnaround time, negative 3 times 2 squared plus 12 times 2 plus 2 equals to negative 3 times 2 squared is a 4, plus 12 times 2, which is a 24, plus 2. Negative 3 times 4 is a negative 12, plus 24 plus 2 is a 26. Negative 12 plus 26 is a 14 feet. And then x of 3, the final time, negative 3 times 3 squared plus 12 times 3 plus 2 will be negative 3 times 3 squared is a 9. 12 times 3 is 36 plus 2. Negative 3 times 9 is negative 27 plus 36 plus 2 is a plus 38. Negative 27 plus 38 is 11 feet. So for part C, the maximum horizontal location, it's going to be one of these three answers, whichever is the maximum, and that's the 14 feet. X max will be x evaluated at a time of 2, so it's reaching the maximum at 2 seconds, and that's a 14 feet. For part D, the x min will also be one of these answers, the lowest value, and that's the 2 feet. That's actually the starting location. X of 0 is a 2 feet. What the object is doing is it's starting at time equals 0 at the 2 foot location. It's moving over, and by the time of t equals to 2 seconds, it's at a location of 14 feet. And then it's turning around and it's going backwards because by the time of t equals to 3 seconds, it's moved back to 11 feet. Now part E is asking the total displacement of the object. That's going to be where it ends up at the final time of 3 minus where it began at the time of 0. From this picture over here, it's the distance between those two. It's this distance right here. Now x of 3 we've evaluated already. It was an 11. And x of 0 we've evaluated. It was a 2. 11 minus 2 is 9 feet. Displacement is how far it ends up relative to where it began. It ends up 9 feet away from where it began. For part F, the total distance traveled, that may be different from the displacement, and it will be if you look at the picture here. The total distance traveled is all of this distance plus all of this distance. It traveled more than 9 feet to displace 9 feet. That is found by taking the position at the final time minus the position at the time that it turned around, which was the 2 seconds, plus the position at the time when it turned around minus the position at the initial time, and take the absolute value so that we have a positive number out of each of these. Now we have these numbers. X of 3 is an 11. X of 2 is a 14, absolute value, to ensure we get a positive number. X of 2 is a 14, and x of 0 is a 2. 11 minus 14 is a negative 3, then absolute value, plus a 14 minus 2, which is a 12. These are representing the different segments making up the travel path. And so the negative 3 was occurring right here. It's a negative because it's actually moving backwards. It's a negative 3 in displacement, but it's actually a positive 3 in distance traveled, and that's why the absolute value is there. So that'll come out to a positive 3. And then that 12 was the distance traveled for this first part, which was a positive number. It was moving rightward. And 3 plus 12 comes out to 15 feet. It traveled a total distance of 15 feet and displaced 9 feet. For part G, we want to find the time or times when the object is at 11 feet, and that's going to be found by taking the position function of time that was given and setting it equal to 11 and solving for all the times where that occurs. Let's subtract 11 from both sides so we can equate it to 0, and that will give us a minus 9 here. There's a common factor of a negative 3, and factoring that out will give us t squared minus 4t plus 3. And we can trinomial factor that into t and t. We need two numbers to multiply to be a positive 3 and add to be a negative 4. Negative 3 and negative 1. So it looks like we have a time of 1 and a time of 3 seconds for each. It will be located at that position of 11. Now the time equals 3 seconds turns out to be the final time, and if we go back here we can see that's the case here. And on our picture the time equals 1 second must have been right here. And that's the other time where it was at 11 feet. Now part H, we want to find the acceleration as a function of time. The acceleration as a function of time is the derivative of the velocity as a function of time, and therefore the second derivative of the position as a function of time. Now we have the velocity as a function of time back in part A. We're going to take the derivative of that. The first term is a constant times t. The derivative will be the constant. And the second term is a constant with no t. The derivative will be a 0. So there's our acceleration as a function of time. It'll be a negative 6